Hello. So this time we are going to do our part 4, which is the offset boring head shaft, right? So this is going to be it's going to have a 3/8 40 thread on it. So each turn of this guy is going to move. Is going to have a lead of 25 thou. So each full revolution is going to move your boring head cutting tool in or out 25 thou. As you can see from this guy, again, nothing incredibly complicated here. A pretty straightforward part. On this print, it says to use 1018. I have a lot of students that have used brass. I would prefer to using brass if I was making this myself, because you're going to probably have a smoother motion. It won't last as long. You know, the brass will wear down quicker than the 1018 screw will, but you know, it's going to be smoother. It'll look cooler, all that fun stuff. So nothing incredibly complicated with this. The only new thing that we're really going to be dealing with is this thread. So we're going to make an external thread on this. So if you haven't noticed yet, when you use the hole wizard, there's a function on there to make an external thread. So let's get started. So like I said, we are going to make a new part. So I'm just going to use my 3 decimal place template and get that guy going. All right, so again, we have a revolved part, or a round part, right? So that just kind of screams out revolve me, right? So same thing, we're going to go front plane, same as last time. We're going to go front plane, we're going to create a center line. Again, don't have to do this. This is kind of a personal preference. Some people probably say that this is a waste of time, but yeah, whatever. Some people used to say about washing hands. All right, so we're going to create this, again, just the general outline of the shape. We're not going to get hung up on making this perfect. The biggest thing that we want to do is we want to try to avoid snapping if possible. All right, and so just rough shape, right? Nothing crazy. So from here, I'm going to do my length dimensions first. So over length is 2 inches 640. Our what is going on with this part? All right, well, I just noticed our print. Something's goofy with our print. So what we will do is I will draw this up. Maybe we'll hold off on master camming this guy until next week. But what we can do is next week I was going to get into assemblies and using assemblies to verify our part. So what we'll do is we'll just draw this. We'll kind of just draw this exactly how it is. We have this gap here of 1/4 of an inch from this section of our part to whatever this is. I don't know what that is. So we'll draw it like it is, see how it works, and then if we need to change something after the fact, we will. I do not remember seeing this before, so good times. All right, so like I said, we're just going to draw it like it is in our sketch. So what that means is we're going to have a point, or let's just make a construction line out here. Okay, so what this construction line is going to be this phantom datum that we have in our blueprint, right? So when I say phantom datum, I'm talking about this little section right here. So we're measuring 1/4 inch from, I don't know, right? We're measuring 1/4 inch out from the end of our part to out here, and then that's what everything else is called off of. So just to kind of keep this how it's drawn, that's what my center line off to the left of my part is. Right, so here I can dimension this off of my part. That's going to be 1/4 inch, right? And now I can just dimension the rest of my part. So from here to here is going to be 2 inches 640. From here to here, 2 inches 340. from here to here is going to be 2 inches, 200. And then from here to here, it's going to be, oops. Let's say this is 1/4 inch as well, because that looks like about how long it is. I'm guessing this is just misdimensioned. But anyway, we're going to draw it how it is, just to, so I can show you how this verification part works. All right, so our diameter here is going to be 420. My diameter here is 675. My diameter here is going to be 374. And my diameter here is going to be 249. Okay, so then from there, I'm just going to do a revolve. Oh, wasn't smart enough to figure out where I want to revolve around. So I'm going to select my center line. And there we go. All right, so we got our shaft here. I'm going to change material just because, brass is pretty, right? So looking back at our print, we have just a couple things to do. So on our print, the only thing we don't have at this point in time is our thread here and this hex on the end, right? So we'll take a broach and you'll drill a hole here, and then you'll take your broach and you'll basically crush out the brass from the inside of that hole. All right, so in order to do that is actually pretty simple. We're going to normal to that. I already have the end of my part highlighted, so when I go and create a sketch, it is going to create that sketch using this as my sketch plane. And then from here, I'm going to go and use my polygon tool. So my polygon tool, I'm creating a hex, right? So a hex has 6 sides. If I wanted to create a decahedron, right, I could do that. It's not what I'm looking for. So we're going to do I guess decahedron is 10. All right, so I'm going to look at this. This is a 3/16 hex. So I believe that is a inscribed circle. So we're going to do 3/16 there. I'm going to click. Oops. I'll create that as 3/16 there. All right, and then from there, all we're going to do is just an extruded cut. So that's going to be a 1/4 inch deep, so we'll just put 250 for the depth. We'll click OK. All right, it's just that easy. All right, and then the last thing we got to do is you have to thread this. Right, so another nice thing about Solidworks, way easier to thread in Solidworks than it is in real life as well. So Hole Wizard depends on the version of Solidworks you have. This is actually relatively new that you can do this external thread in this manner. It used to be a lot more complicated. You used to have to create a helix. You have to create a helix down here. And you know what? Just for how about I show you the easy way, and I'll show you the hard way. So if we create a thread. All right, so it's going to give me a warning. So to create a thread, I have to create my thread location. So it's going to say, what's the edge of the cylinder that you're creating this thread on? So also fun fact, it will decide really weird threads based on the diameter of the shaft that you're talking about. All right, so with this, it's a 374 diameter. Right? So you would think that it would default to a 3/8 type thread, but in fact it defaults to a number 080. I'm not sure how you make a number 080 around around that, but anyway, so we're going to have to. Oh, I forgot about that. So what we're going to have to do is we're actually going to have to create the pitch of this because this is a non-standard thread. So if we think about this, right, if we do our thread, it's going to have a standard list of threads that are available to us. So for 3/8 threads, the standards they have are 3/816 and 3/824, right? So UNC, which is the 16, and UNF, which is the 24. Well, that doesn't really work for us because we need a 3/840, right? So we can go in here and change this. So if we go down to our pitch, we're going to override our pitch, and we're going to say this is 1 divided by 40, or 25 thou. All right, so this is an inch die. You know, one way to think about this is if I had to thread this with a tool other than the single point threading tool, what would I use? All right, so as an external thread, I would create a die, or I would use a die. If it was a internal thread, I would use a tab. So, so this is our thread location. So this is going to be our optional start location. So I'm going to have this as our start location, and then we're going to offset this very, very slightly. Well, we can offset it however much we want. We'll say 0.1. All right, and then end condition. So we're going to do a blind, and this is going to go up 1 inch 70 or 1 inch 700, 1.7 minus 1/4 inch. What's going on here, guys? Well, it doesn't like my thread. Okay. Well, you know what? We'll do it the hard way. And this is not something you have to do. In fact, this is probably not something you want to do. But I'll just kind of show you how I used to have to do this to create an external cosmetic thread. So if I go here, right, and I create a, well, all right. So what I'm going to do is I'm actually going to create a reference plane because I need to start this thread off of this surface. If I start it on this surface, it's going to have half a thread in my part and half a thread out. Right, so this thread's going to start centered on my part, and it's going to ravel or spiral around. So I'm going to create a reference plane. I'm just going to offset this off of that part by 100 thou. All right, so I can create a plane in reference to almost anything. So in this case, what I'm doing is I'm saying I want to create a plane based off of this surface. So what it's going to do is by default, it's going to create that plane parallel with that surface, which is exactly what I want. I can change it after the fact to be have used different relations to figure out where it is. In this case, I only need one reference for this plane because I'm creating an offset plane. All right, so really the only reference I need is what it's parallel with and then how far away from that plane it is. And I can flip the distance, I can increase, decrease the distance, whatever. And I'm only going to create one plane. Right, so I'm going to click OK. So now I have this plane kind of hanging out here. So I'm going to normal to this plane, and then I'm going to create a sketch on this plane. And so now I'm going to use a tool that we have not used yet called Convert Entities. So what convert entities does is it creates geometry that matches other geometry in a different sketch. So what does that mean? Well, if I'm going to create a spiral, I could just draw a new circle on that in my sketch, or I could take this circle and convert entities. And hopefully you saw what happened there, right? So I'll just undo it real quick. So if I select that circle and select convert entities, it's going to take that exact same circle and it's going to put it on my sketch plane. It's going to copy it and put it on there. And at the same time create a relation between my sketch here and the original geometry. And that's what that on-edge relation is. So the on-edge relation just means that the edge of this line matches the edge of this line, right? So in this case, the edge of this circle matches the edge of my original circle. And the reason why this is useful is if I need to change this circle, right? So if I go in here, if I go into my revolve, go into my sketch, oops, wrong button. So I'm going to close this sketch and I'm going to open my revolve. And so if I go in here and I change the diameter, right? So I'm going to go in and I'm going to change this 374 diameter. So instead of saying 374, I'm going to say this is 450, right? So obviously significant, much larger. And when I click OK, what you'll notice is my plane on plane 3 in sketch 8, it changed to match my diameter, right? So because that's on edge, it just means it's going to match this circle. And I don't have to go back. I can just hit undo, and then close. All right, so anyway, so I have my original geometry for this guy. I'm going to hide this plane at this point. If I right click on it, there's a little eyeball with a line through it, and that will hide that plane so I don't have to look at it. It's not in the way anymore. That plane will show up for the rest of the sketch if I don't hide it. And I like having a clean workspace. So our next step is to create a helix. All right, so our helix is going to be made using our features. So if we go to features and over here next to reference geometry is curves, we're just going to create a helix and spiral. So, oops, probably shouldn't have hid that yet. So we're going to go curves, helix, and spiral. We'll start on that plane. There we go. Okay, so we're going to reverse that direction. We're going to change our pitch to 1 divided by 40. And so there are a few different ways we can do this. We can hold down our revolutions button and it's just going to keep counting up. Or we can do a distance. So I know this is 100 thou off my part. And so that's going to be 170. So my height here is going to be 1 inch, 700 minus 0.15, 150. And that will put my thread all the way up. So now I have a helix. I am still not even close to being done, right? So I already have what? I already did my created a plane, created did my convert entities. Some 3 steps in already. I'm not even close to having a thread. All right, so at this point, what I want to do is I want to figure out where on this spiral or where on this part my spiral starts. So my spiral starts right there. So what I want to do is I want to select the plane that is going to be coincident with that point. All right, so this point is going to be starting on our top plane. So I'm going to normal to my top plane, and then I'm going to create a sketch on my top plane. Again, I'm going to hide that guy so I can see where this guy starts, right? So if I'm creating this, what I want to do is basically want to create a triangle, right? And so at this point, I'm just going to zoom in. I'm just going to create a triangle. And then I'm going to dimension this from the center point of here to there. And that's my thread depth. So what's my thread depth for a 3/8 whatever? I don't know. I'm just going to guess. So let's say 18 thou. It looks about right. What I don't want is that to be too big, so it looks like it might be kind of close. So let's just say it's 15, because I think that basically what I don't want to do is I want to have a flat here. I don't want to have these triangles intersecting with each other as they wrap around here. And you'll see what I mean here in a second. So now I have two things, right? I have the shape, I have the shape of this thread, which is defined by my triangle, and I have the path of this thread, which is defined by my helix. So at that point, some of you are probably like, well, I know what we're going to do now. I know what we're going to do. We're going to use a swept cut, right? So what we're going to do is that's exactly what we're going to do. Good guess. So our swept cut, we're going to take our profile. So our profile is what we want to cut, and our path, which is the spiral that or helix that we're going around. Right. So now that highlights all that yellow is all stuff that's getting cut. So I'm going to click OK. Right, and that creates a cosmetic thread. Now, you might be looking at that and going, hey, Paul, that's not what threads look like, right? I mean, what does a thread look like? At the bottom of the hole, we have a radius, and that is a huge flat. So, just like with anything else, we can go back and we can edit this after the fact, right? So we're going to go in, we're going to say, I'm going to change that to 18 again. That's 18, but I'm also going to put let's say a 10 thou radius on the bottom of this triangle. Now, let's say a 5 thou radius on the bottom of this triangle. That looks pretty big. That's probably too big, right? So we'll go back. Let's change it one more time. So let's change that to like 2. And I'm going to push that down about another couple thousandths. Click OK. I'll rebuild here. Oh, yeah, that looks better. That looks much better. That looks more like a real thread, right? Got a little bit of radius in the bottom, just a little bit of a flat on the top. But we still have all this stuff visible, right? So by default, it's going to still keep my spiral visible. Well, I'm going to hide that. I'm going to hide that. Nope. Just not sure what that pink circle is. But anyway, so now you can kind of see we have a cosmetic thread. We cannot toolpath this as far as saying, you know, this is the depth of my thread, just go to this point on my part. We don't want to do that. Still want to use our thread depth charts and our pitch diameter charts and all that to kind of figure out how deep to go. So anyway, before I stop, I'm just going to save this as part number 4. Don't do what I just did where you create your entire part and then save it after the fact. SolidWorks does like to crash. So not quite as much as Mastercam though. But anyway, so there you go. We got our part here. There is one thing I would change though. So when we're creating this geometry, when we're creating our parts, one of the things we kind of want to think about is how this part is actually going to be made. right? So what kind of tool are we going to use to make this? We're going to use a single point tool, right, on a lathe. We're going to use a cutter. Well, the cutter has a radius on it, so I'm never going to have actually a sharp corner. So one of the things that I like to do is go in here, because if we're going to use our assembly to kind of figure out what our clearances are, we want those parts to be as accurate to how we're actually going to make them. So if the only tool that you have is a 1/32 radius insert, well, then you want to do this, right? So if we go through here on all these internal corners, this is going to show me, this is going to be more accurate to what this part is actually going to be. Hopefully it doesn't break anything, right? So hopefully that makes sense why I did that. And if it doesn't, it will next week when we put this guy together. So anyway, like I said, this part is not really absolutely necessary. I'll mess around with the threading tool a little bit more because I feel like that should have done it, but for some reason it didn't. But anyway, cool threads on there, all that fun stuff. The disadvantage about doing this is this file is now huge. So if I go to save as, so this is part number 4. This is, well, about 10 times bigger than, more than 10 times bigger than the next biggest part. Right? Definitely not because of everything that has going on, but really only because of, I guess you probably can't see my save as, can you? No, you can. All right, cool. So, yeah, right. Part 1 is only 41 kilobytes. Part 2 is 153. Part 3 is 109. This is 1739. This is 1.7 megabytes. Right. So that's the disadvantage of doing this, is that you are creating a much larger file. So that's going to take longer to load. If you have a lot of these in an assembly or a lot of them open on your computer, this is going to be a resource hog. Okay, so this is not, like I said, not necessary. Really, the only reason to do this is to make your part look like what it's going to look like in real life. So keep that in mind. But anyway, so tomorrow we will be talking about how to actually toolpath this in Mastercam, this and part number 3. So hopefully we can get all that done this weekend. If you haven't started Mastercamming your other parts, if you haven't started drawing your other parts, you really need to get that on that. This is Thursday. This is all going to be due Sunday night. Unless you're having severe technical difficulties, I'm not going to be accepting late work. And if you are having extreme technical difficulties, you need to contact me now. Not tomorrow, not later today. Now, email me or text or whatever. So anyway, again, if you have any questions, get in touch with me. I'll just say it one more time. If you have any questions, get in touch with me. Be safe out there. I will see you tomorrow, and have a good day.